Welcome to the world of science and technology. Today's topic of discussion is Faraday's law of electromagnetic induction. This law was discovered almost 200 years ago. In 1831, so in the year 1831, this law was discovered by Michael Faraday. And this law is popularly known as Faraday's law of electromagnetic induction. And this is the third law in Maxwell's four equations of electromagnetism. And this law tells about electromagnetic inductions. Means just by using a magnet and a coil of wire, you can generate electricity. It is so simple. Yes, it's so simple. Just using a magnet and a coil of wire, metallic wire, such as aluminium or copper or any other metal. Okay, so by using this combination, you can easily produce or generate electricity. But one thing you have to do, you just keep a magnet on the table, and nearby you just place a coil of wire. In that case, no electricity will be generated. One thing you need to do, that is you have to produce a relative motion between the coil of wire and the magnet. A relative motion between them must exist. Means either the magnet should move with respect to the coil of wire, or the coil of wire should move with respect to the magnet, or both should be in motion with respect to one another. Both can move. Okay. In all these three cases, relative motion exists, and if relative motion exists, then in that case there is a change in the magnetic flux. Since magnet is present, that means magnetic field is there. That means magnetic flux exists. Okay, magnetic field passing through a surface, the total amount is known as magnetic flux. So magnetic flux exists, but whenever there is a relative movement or relative motion between the coil of wire and the magnet, in that case there is a change in magnetic flux. And whenever there is a change in magnetic flux, it induces electricity in the coil of wire. And that way electricity is generated. And that electricity we are using in so many cases. For our lights, fans, mobile charger, even wireless charging, transformers, so many things are there. Even today's electrical vehicles, all these things are dependent on electricity. That was discovered 200 years ago by Michael Faraday in the year 1831. So this discovery is no doubt a wonderful discovery. We should all thank to Michael Faraday for his discovery. Actually, without electricity, today's generation cannot think even how to live without electricity. Okay, because we are fully dependent on electricity. Without electricity, really we cannot move a bit. Anyway, so this was all about, no, this was not all about, mobile charger. A transformer is there inside the mobile charger, okay, and transformer uses the same thing, means that induction process. So you can see the equation on the screen. It is equal to minus n d phi dt. Means induced EMF or electromotive force is equal to, according to the law, Faraday's law of electromagnetic induction, according to the law it is equal to minus n d phi dt. And you can see on the screen other forms also. But this is the fundamental form, which is equal to minus n d phi dt. Here n is the number of turns in the coil, phi is the magnetic flux, and t is time. So d phi dt is rate of change of flux with respect to time, rate of change of magnetic flux with respect to time. N is the number of turns. And in other two forms, integral form and that curl form, here in that case n is absent. You can see n is not there. So why n is not there? Because in those two cases n is assumed to be 1. Number of turn in the coil is assumed to be 1. That's why n is absent. Okay, but those are not new forms, but the same thing is used. That is the fundamental law of electromagnetic induction, which is given by minus n d phi dt. So you can see the induced electromotive force is proportional to number of turns. That means if number of turns in the coil is more, then induced voltage or the induced EMF will be more. If magnetic flux is more, means if field strength, magnetic field strength is more, in that case induced EMF will be more. And if rate of change of magnetic flux is more, then in that case also induced EMF will be more. Okay, mathematical, it is so simple mathematics, so it easily implies all these things. It easily implies all these things. Okay. Anyway, so I have already mentioned the uses or applications of this. So in so many things, countless number of devices are there where this technique is used. Okay. And in case of wireless charging of mobile phones, smartphones, okay, wireless charging, in that case also in your mobile phone, in that case a receiver coil is there. And in the equipment which provides that charging facility, they actually create changing magnetic flux. Okay, changing magnetic field they create, those devices. And that way your mobile phone is charged wirelessly. Again, in transformers, the voltage is stepped up or stepped down by using the same procedure, means that is Faraday's law of electromagnetic induction, in that case is used. Okay, but in not all the cases magnetic, anyway, so I should finish over here. At this point I should finish this lecture. Okay, the remaining thing will be discussed in a separate video. So this was all about today's topic, Faraday's law of electromagnetic induction. Okay, so this is the end of this video. Thank you for watching this video.